Alright, limits review. Let's get going. Alright, I'm just going to do the odd problems today. Alright, problem 1. The key thing here. What's the limit as we approach a -1 from the right side? So in this situation, as we come from the right side, we are approaching the number 4. Right. With this problem, if it asks for the left side, our answer would be -4. If it asks for a limit of everything, is there a limit as we approach -1? There would be no answer because they do not match up. Alright, so the limit as we approach -3. So as we look, as we come down this, as we come around here, they merge the exact same thing. As we go towards -3, we approach -3. Now just jumping over to problem 4 just because. -1 coming from this way. Coming from this way. Oh no, we go to here, we go to here, they do not meet, the limit does not exist. Alright, problem 5, time to graph. So for our top equation, I'm going to plug in -1 first. So you got -1, you got -2. Okay. This is a closed dot. We have a slope of -1, and we're talking about less than. For the second part, we have our y-intercept at 1. We're coming from -1, which is an open dot, and we're going that way. Right, so the question is, the limit as we approach -1 from the negative side. So we are coming this direction. So our answer to this problem is -2. That's 7. What's the limit as we approach -2? Coming this way, merge, join at the exact same number, which is 4. Problem 9. As x approaches -infinity. Alright, so we're going this way. There are no other vertical asymptotes in this situation. It's following the slant asymptote. It's taking that slant asymptote all the way down to -infinity. Alright, looking at 10. Key thing here, -4. Alright, so we pull out a 4, we're left with x plus 4. That leads to -4 being our vertical asymptote. So there's our first thing. Now as we look, on the right side, we're going up. On the left side, we're going down. So as we approach -4, as you approach -4 from the positive side, your limit would be infinity. As we approach -4 from the negative side, your limit would be -infinity. The overall limit from -4, since these are different, is that it does not exist. Alright. Problem 11. Now we got to do a little graphing here. Alright, so how am I going to graph? Factor and cancel, start off if possible. X minus 4, x minus 3, over x minus 3, leaves it x minus 4. But we have a whole at, in this case, 3. What do we got? 3, -1. Alright, so -4, up 1, over, up 1, whole, dot, dot, dot. Alright, so even though there's a hole coming from both sides, we approach -1, we approach -1, our limit is -1. Alright, so whether there's a hole or not there, if there's a hole, the limit's -1. If there's no hole, the limit's still -1. Alright, problem 13. Alright, x plus 2, x minus 2 over 2x squared. Alright, two vertical asymptotes in this situation. x equals -2, x equals 2. Right? So we have this because we're not able to cancel anything from our denominator. All right, the horizontal asymptote is our ratio of lead coefficients, which is 2 over 1, which is 2. That is because the degree here is 2, and the degree here is 2. Do we have an x-intercept, y-intercept? If we plug in 0, we get 0 over 0. So our x-intercept, y-intercept is that point. Now, based on that, right, do we have a spot where we pass through the horizontal? Now, with the work you have, you could plug this into your calculator and get a visual view. I'm just going through the whole algebra process. So 2x squared, or x squared minus 4 equals 2 over 0. So this would give us 0 equals 2x squared minus 4. So we would divide by 2, 0 equals x squared minus 4. 4 equals x squared, x equals positive -2. Well, that's not possible because those are our asymptotes. So it's not passing through our horizontal. So that means our graph's looking like this, which is giving us this, which is giving us this. So the overall question, as we go to negative infinity, where is this going? All right, where is this going? As we go to negative infinity, we're going that way. Our limit is negative infinity. Did we need to really go crazy and graph this in this situation? Not really. I'm not negative infinity. Lose my mind. Why do we not have to go crazy and graph this? What I was saying is that as we go to negative infinity, what are we approaching? 2. What is 2? A horizontal asymptote. And that's the key thing when we're talking about limits dealing with infinity. So I went crazy and started graphing to give you all that discussion, but I don't know how necessary that was. This one, maybe a calculator would have helped you out in the end. All right, problem 15. We got a vertical asymptote at -1. Horizontal asymptote, there is no horizontal asymptote. Right? There is no horizontal asymptote. So that means in this situation, do we have an x-intercept, y-intercept? We plug in 0, we get 0, 0. All right, so we got that point again. And now the question is, where's this next point? So if I plug in 1, so I know it's either going down from that point or it's kind of up from that point as we approach. Well, let's get the slant asymptote here. So if I get my slant, I got -1, 1, 0, 0, 1, -1, -1, 1, 1. That doesn't matter. This gives us our slant as y equals 1x minus 1. So y equals 1x minus 1. There's our slant. All right, so there's the key thing. Our graph has to look like this. So there's where our dot is. So the question is, as we approach -1 from the positive side, right, -1 from the positive side, we're going this way, and we're going up, and we're going to positive infinity. So the limit of -1 from the positive side is just infinity. 17. So the key thing with this is a graph. So for those of you, y equals 1/2 x plus 2. So we have a hole at 2. That doesn't exist there because in this situation we have the point when x is, I read that wrong. So this is saying at 3 we have a hole because the value is 3, 2, which is down there. Now remember, even though the graph looks like this, whether the graph looked like this or it was a perfectly straight line, the key thing here is that as we are approaching 3, right? As we're approaching 3, in this situation, right, both the left and the positive side approach 3.5. So that dot, whether that dot below is there or not, limits 3.5. If this was a solid line, limits 3.5. So all 3 of those options, exact same answer. All right. Problem 19, option 1, plug in. -1, 1 minus 4 over 1 minus 6 plus 8. So we got -3, we got 3, we got 1, 9, 3, 1. So we plugged in, we got an answer. We're good. All right. Problem 21, plug in. 5 minus 5 is 0. Not okay. So method 1, plug-in doesn't work. Now, what I was telling my students a lot of times is, 1, can you plug in? 2, can you factor and cancel? 3, can you do the conjugate? 4, what's a graph? Get a visual view. So for 21 here, I plug in 5, I get 0, which doesn't work. Can I factor and cancel? Let's see. X minus 5, X minus 5, leaves me with X. Answer is 5. There it has it. 23. All right. Can I plug in? I plug in, I get 0 in the denominator. Can I factor and cancel? No. Time for the conjugate. So I have X minus 5 times rad X plus 4 plus 3 over X plus 4 minus 9, which gives us in this denominator X minus 5. Cancel, 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 leaves us with rad X plus 4 plus 3. We plug in, we get 6. All right, 25. All right, so here, can we plug, we're talking about infinity. All right, so the plug-in doesn't work, no factor and cancel, no conjugate. For this, I think it helps to get a visual look. All right, so what I know here is that since a positive lead coefficient, this graph's going up over here. Since it's an odd degree, it has to end in opposite directions. Now this graph may not be perfect. I have no idea what the intercepts are. It doesn't really matter to me. I just know that as I go towards negative infinity, based on the lead coefficient and degree, this has to go down. So this is just strictly based on higher degree function graph rules. 27. Alright, key thing, degree of 1, degree of 2, larger when denominator is larger than numerator. Our horizontal asymptote is 0. 0 is the answer to this problem. Alright, let me just check a little something over here. If anything different on these other sides. Nah, nothing overly different. Same ideas. Alright, hope this helped everybody. Alright, if you have questions.